Okay, so in this problem, number 2, chapter 40, we got a Ferris wheel, and the Ferris wheel, the diameter is 10 meters, so the radius is 5. Let me draw that a little bit better. So this is 5 up here, this is 5 right here. The center is 6 meters off the ground, so there's an extra 1 unit there. And when Alan is 8 meters high, which is everything above this line, let's say about here, so this is 8 meters. So when Alan's above that line, he's nervous. Okay, so that would mean that this part right here is 2 units because it's 5 more below it and 1 more below that, so that would make 8. So the question is, how many seconds of each revolution is Alan nervous? And 1 revolution, so 30 seconds is 1 revolution. Okay, so really what I can do here is, if I can figure out for how many degrees he's nervous, then I can use that to figure out how many seconds he's nervous. So if right now what I've got is that this part right here is 2 and the radius is 5. So if I call, let's do this, if I call this angle right here theta, then this is identical to it on the other side. And using right triangle trig, if I show you that triangle by itself, this part's 2, this part's 5, this part's theta. Well, this is the adjacent side and this is the hypotenuse. So I can set up cosine theta equals 2 over 5. Theta is going to be cos inverse of 2 over 5. And that comes out to be about 66.422 degrees, which you should probably store, right? Well, he's nervous for not 1 theta, but 2 theta degrees, right? So if I double that, then I'm going to get about 132.844 degrees. And again, you should, store that. So Alan is nervous for 132 degrees out of the circle. So 132.844 degrees out of 360, he's nervous. And it takes 30 seconds to go 360 degrees, because that's 1 revolution. So the 132 matches up with however many seconds he's nervous. So the way to read this is, it is the nervous degrees over the total degrees and the nervous time over the total time. So if you solve for x when you do this, you end up with x being about 11.07 seconds.